All right, kids, last one for today. Now, the last one that we're going to look at is what if it's not written as a sequence? What if it's just given to us as data? Like, let's just say that we have a graph that is a chart that tells us the amount of time and the number of cookies that Mr. Bywater can eat in that amount of time. Okay, so let's say that after 1 minute, Mr. Bywater has eaten 6 cookies. And after 2 minutes, Mr. Bywater has eaten 12 cookies. And after 3 minutes, Mr. Bywater has eaten 18 cookies. Okay, and then after 4, of course, 24. Okay, now this isn't written in the same way, but you can look at it similar to how we were looking at the other one. Recognize that it's a pattern going from 1 to 2 to 3, that the x values are changing by the same amount every time, and therefore let's see if we can recognize whether there's a constant difference or not. And so if we look at this, you should hopefully be able to see that each time that x increases by 1, y is adding 6, right? So y is adding 6 every single time. So that means that we have a constant difference of 6. Now, if the constant difference is 6, right, that tells us a couple of things. Number 1, this is an arithmetic sequence. Number 2, we can now look at this and say, okay, is this direct variation? Okay, now probably the easiest way to do this is the last one that I taught you, which is to use a proportion. Just go the time over the number of cookies equals time over number of cookies. Cross multiply, 12 equals 12. It is proportional. Yes, you should check the others just to make sure, but you can see, right, if I did 2 over 12 and 3 over 18, 2 times 18 is 36, 12 times 3 is 36, there it is again. This is arithmetic sequence. It's linear because it's an arithmetic sequence, and last of all, because it's linear and proportional, that means that it is direct variation. So we'll put direct variation with a smiley face. Yes. All right? Pretty easy, right? Even with that. Now, maybe let's try something a little bit more difficult. What if it's not going up by 1? What if I take a swimmer or a runner, maybe a runner that's running a certain distance, okay? And he's running, and we're going to time him as he goes 400 meters, and as he goes 800 meters, and as he goes 1200, right? And so you can see that my distance is increasing by the same thing every time, right? Now this is my x value, okay? Now the y value is going to be the amount of time that it takes him to run that distance, okay? And so we're going to have this time. Let's say that he does 1 minute and 32 seconds, and then he does 3 minutes and 4 seconds, and then he does 4 minutes and 36 seconds, and then the 1600 he does in 6:08. All right? So let's look at this information. Is this an arithmetic sequence, and is it a constant difference? Is it then a direct variation? Let's consider that. Okay, so first constant difference, 3 minutes and 4 seconds minus 1 minute 32 is 1:32. Again, to get from here to there, and you can do the subtraction on your own, right? I'm just doing it quickly so that I can fit it in the time that I got, and then again, 1:32. You'll notice that every single time we're adding 1 minute and 32 seconds. That means that the constant difference is 1:32. Now this is only because the x value is increasing by the same thing every time as well. Okay? If your x is jumping around all over the place, then you're not going to be able to find a constant difference, or if there is constant, it doesn't mean anything. But since they're both increasing by a specific rate every time, that means that you now have a constant difference. Since you have the constant difference, you can now check whether it's direct variation. You can go ahead and try any of your methods. I'm going to leave this up to you. Go ahead, try it out. Hopefully you get that